In this next example, we have sine squared times the quantity 1 plus cotangent squared equals 1. This is where we would want to verify that this is an identity. We'd want to verify that the stuff on the left is equal to the stuff on the right. Now, it's not known initially that this is true. This is just an expression that we want to verify. It could very well be false, okay? And so what we want to do is we never assume this is true. We never just take this to be true. So in order to verify a trig identity, there's 3 different approaches you can take. One is you can start, I'm going to write these up on the other side here. So one is you start on the left and simplify to the right. Okay, so you might start with this expression on the left, do some simplifying, and hopefully you get 1 at the bottom. You get the right-hand side at the end. That's one approach. Another one is to start on the right and go to the left. Okay, so in this case, 1 is about as simple as it gets, right? There's not a whole lot you can do to 1 to simplify it down to the other stuff. So that might not be a good approach. But there are times where both expressions are basically equally complex, and you might choose to work with the right side as opposed to the left side and try to work that way. So that's an option, even though it might not really apply in this example. So you could start on the right and simplify to the left. Okay, so that's an option. The third option is actually where you do some work with the expression on the left, you do some work with the expression on the right, and perhaps they simplify to the same thing. And if they simplify to the same thing, then they must be equal to each other, okay? So you work with both the right and left sides, and get them equal to the same thing. Now, of course, there are probably better ways to say that, but that's ultimately the goal, right? Okay, so on this one, I'm gonna do the top option here. I'm gonna start on the left because the left is obviously more complicated than the right. So if I simplify on the left, hopefully we'll get to the right side. Okay, so I'm gonna ignore this 1 basically. I'm gonna forget that it's even there until I get to the end. I always have it in my mind, I guess, a little bit that that's the goal, is to get to that point. But I'm not gonna use that at all in the verifying of the identity, okay? So I'm going to start on the left. Now I could turn the cotangent into 1 over the tangent or the cosine over the sine using different identities, but as I'm looking at this, I know 1 plus the cotangent squared applies to a Pythagorean identity. Remember, 1 plus cotangent squared is actually the cosecant squared, okay? And so we could do that replacement. We could say the sine squared theta times this thing is equal to the cosecant squared theta, and that's using a Pythagorean identity. And notice on that, I did not write the equals 1. I don't know that it equals 1 yet, okay? So we have to prove that. That's what we're trying to prove. So I said 1 plus cotangent squared is cosecant squared. I know that the cosecant, so that's simplified a little bit, but I know that the cosecant is 1 over the sine. So I can get things in terms of the sine now a little bit easier. So I know sine squared theta, this would be times 1 over sine squared theta, right? Cosecant squared is 1 over the sine squared. So that's using a reciprocal identity. And now I've got sine squared times 1 over sine squared. Well, a sine squared on top, a sine squared on the bottom, they cancel, and I'm left with just the 1, which is what we should have, right? That's what we want on the other side. So that's done by canceling common factors. And we have proven our identity, okay? So I've proven then using these 3 steps that the sine squared times the quantity 1 plus cotangent squared is equal to 1.